Hello, all our grade 11 mindsetters. Hope you guys have yourselves ready for an awesome show of mathematics with myself. And of course, as always, I'm not rolling alone. We've got an awesome teacher in studio today with us. Sitha, how are you?
Ngiyaphila sisunjani? How are you, baba?
I'm good. Sitha now speaking Zulu, and I'm like, I still have to interpret it. Well, Sitha, what do you have for us?
We're doing Euclidean geometry today with the grade 11s. Yeah.
All right. Wow, that's interesting. Mindsetters, remember that this show is all about you. So all you have to do is just get in touch with us through our social media platforms, and that is at Facebook, Mindset Learn Extra, or you can also tweet us on our Twitter handle at Learn Extra with an X. Or you can also download yourself some awesome study material, notes, guides, or even shop for some textbooks on our online shop, and that you can find on our website, that is at learn.mindset.co.za. And Mindsetters, remember that we've got a competition running, and that is the awesome Casio calculator competition. All you have to do is log on to Curio if you're a new member and register and answer the test yourself questions on there correctly to stand yourself to win this awesome Casio calculator. And that will be it from me. Let us continue with the show. Sithe, take it away.
All right. Thanks, Queen. All right, guys, let's get moving. Grade 11s, I've got a challenge question for you here. I know most of you it's not going to be that challenging, so we need to get more people getting correct answers. So you've got, in the given diagram, O is the center of a circle, NAM, okay? And OPA is perpendicular to MPN, MN equals to 48 units, OP equals to 7 units. Calculate with reasons the length of PA, right? So you can work on your challenge question now, okay? Right, guys, I'm just gonna go through the your summary for your Euclidean geometry. I've put your Euclidean geometry stuff that you need to know, but it's random. It's not according to theorem 1, 2, 3, and whatnot. So these are the theorems that you need to be aware of in your grade 11. So the first being the line joining the center of a circle to the midpoint of the chord is perpendicular to the chord. And when you're answering your questions, you can say line from center to the midpoint of the chord. And the second one, the angle which an arc of a circle subtends at the center of the circle is twice the angle it subtends at any point on the circumference, okay? So when answering questions, you can say angle at the center is twice angle at the circumference, okay? And then the third one, the angle subtended at the circumference by a diameter is right angled. So, and you can say angle in the same semicircle. Now, and 4, angles in the same segment of a circle are equal. Okay, so that's angle in the same segment. 5th, the opposite angles of a cyclic quad are supplementary. Okay, and then number 6, a tangent to a circle is perpendicular to the radius of the at the point of contact. 7, 2 tangents drawn from the circle from the same point outside the circle are equal in length. And then 8, the exterior angle of a cyclic quad is equal to the interior opposite angle, right? And then the last one being your tan chord theorem. Now, this is just a summary, so you've got it in your note, but my duty is to get onto your questions, how to answer your Euclidean geometry questions, okay? Right? First question. Complete the following statement. The angle between the tangent and the chord at the point of contact is equals to the angle subtended by the same chord in the alternate segment. Okay, right. Now, question 2. Now, we have to be very careful here, guys. You've got your sketch. Now, you need to make sure that you read the statements before answering these questions. So, in the first one, in the diagram, A, B, C, D, and E are points on the circumference, okay? So you've got A, B, C, D. So they're there on the circumference of a circle such that, okay, AE is parallel to BC. So you've got your AE parallel to BC, okay? And BE and CD produced meet in F. GBH is a tangent to the circle at B. Then B1 is 68, okay? They've indicated here it is 68. And F is 20. Where is F? Oh, there is 20. F is 20. Find the size of each of the following. Now, E1, okay? So you've got E1 is here, right? Now, from that first statement, they talked of the tan chord theorem. We're given a 68 here, so this is 68. This is a tangent, okay? This is the chord, and this is the angle in the alternate segment. Okay, so an angle between the tangent and the chord, and you see that you've got a 68 here, and E1, okay? So this is tan chord theorem. So you'll say E1 equals to 68 degrees, and your reason is tan chord theorem. Okay, right. And then now we move on to the second one, B3. So you need to find B3, okay? Now, this is where B3 is, okay? Now, looking at our diagram, so we've got this as 68, right? And now, the other thing that they told us is that AE, so you see where AE is, this is AE, is parallel to BC. And if you look, remembering your grade 8 geometry, this forms a Z shape, okay? So this and that. So we call those alternate angles. So we've got, this one will be 68 as well. So you conclude by saying, okay, B3 is 68 degrees, right? Alternate angles. And because AE is parallel to BC. AE is parallel to BC. Right. Now, guys, we move on to the next one. Let's just indicate the angles that we've got. We've got 68 here, and then 68 there as well that we worked out previously. Now, find the size of D1. We need to work out the size of D1, right? Let's check where D1 is. There is D1, right? And we've got AED, sorry, you've got your BEDC. Can you see that these points, guys, they are on the circumference, and you've got this angle here and this one here. So this is a cyclic quad. So BCDE is a cyclic quad, and we've got an angle outside, all right? So we conclude by saying D1 is also 68. It's equals to your B3, all right? And we've got opposite angles of a cyclic quad. Okay, so you've got 68 there as well. Okay, right? Opposite angles of a cyclic quad. Now we move on to the next one. We need to work out what E2 is. Okay, so E2, there is E2, right? Now, guys, please remember, you are in grade 11, but the info, your Euclidean geometry for grade 8 and 9 still applies here. If you look at this triangle here, you have that, right? This is EFD, it's not EFF. So you've got, this is 68, and then 20, and this is a triangle, and you want to work out that angle, right? So now in grade 8, you talked of the exterior angle of a triangle. Now, so in other words, we conclude by saying E2, it's equals to 68 plus 20, which gives us 88. And our reason is exterior angle of a triangle. And our triangle in this case is EDF. Triangle EDF. Right? So now, next, we need to find C. Now, C is here, okay? Right, guys, and you can find it in different ways. We've got this as, this is 80, this is 88, okay? Now, if you look at this, this is your EDCB. It's a cyclic quad, right? And you know that opposite angles of a cyclic quad are supplementary. So what you can do is adding C to E, so you know that C plus E will give us 180 degrees, okay? So the sum of the two. So you've got C will be equal to 180 degrees minus 88, and then 180 minus 88, that's 92. So opposite angles of a cyclic quad, so that is 92. Or if you look at this triangle, this big triangle, you've got two angles and you have one unknown, okay? So this is 68, there is 20, you're missing that. Now, to complete that triangle, you need to add 68 to 20 to the unknown equals 180 degrees. So we have 68 plus 20, which is 88, plus the unknown equals 180 degrees. Therefore, the unknown, which is C in this case, so C will be 92 degrees. Okay, so that answers our first question. Our Queen, any questions or whatever?
No questions yet from our mindsetters, but I do see that they are actually getting on with the challenge questions, so that is pretty good.
Okay, thank you very much. All right, guys, with the next question, I'm just going to give it to you, all right? So you sit, you do it at home, and then after the break, we work together. Right, so in question 2, in the diagram, M is the center of the circle, and we've got a diameter AB that is produced to C, okay? So we've got that AB produced to C, okay? And ME is drawn perpendicular to AC, such that CDE is a tangent. Okay, so we've got the tangent there, CDE is a tangent, and ME drawn perpendicular to AC, so a tangent and, to the circle at D. ME and the chord AD intersect at F. MB is twice BC. Then you've got your diagram there. First question, if D4 is X, write down with reasons two other angles that each equals to X. You've got your 3 marks there. And then your next question will be, prove that CM is a tangent at M to the circle passing through ME and D, okay? And then your next question, you need to prove that FMBD is a cyclic quad. Okay, Quinn, is it fine if we just take a break and then we come back and work with it?
All right, but before we take a break, we have a shout out from a mindsetter, but actually we'll do that after the break so that we can get more information on that. Let's take a quick ad break. We'll see you after this. Welcome back, Mindsetters. You are still tuned into the grade 11 mathematics show with myself and Sihle. And I'd also like to just say a quick shout out from a mindsetter. Joel Mbata says, can you please say hello to all my grade students from Inkunzi Secondary School? So hi, all the grade students that are together with Joel from Inkunzi Secondary School. And also we have a question that asks, how do you guys enter the water games competition? All you have to do is simply go to watergames.co.za, and all their information is there on how to play the game and how you can win yourself the prizes. Sitha, let's continue.
Okay, let's continue. Thank you very much. We can see some people learn in Nkunzi. I know where Nkunzi is.
Oh, wow.
Yeah,
That's nice.
It's somewhere in South Africa. All right. Okay, guys, we continue with question 2. It says in the diagram, M is the center of a circle. So we've got M there, all right, as our center, and diameter AB, right? So remember, we've got a diameter, and the angle subtended by the diameter is 90. AC such that CDE is a tangent to a circle. So this is a tangent, so EDC is a tangent to the circle D. ME is a chord, and they intersect AD at F. MB is 2BC. Now, question number 1. If D4 is X, write down with reasons 2 other angles equals to X. All right? So we have D4, this is X, right? Now, but we know that this is a tangent, okay? This is our tangent, okay? And we are told that this is a chord, okay? And if I continue with that, so I've got the angle between the tangent and the chord, that it is X, right? So the other angle that's going to be X is when I move this direction and then I get that angle there. So A will be equals to X. So angle A is X. You can say this is DAB is X, and your reasoning, it's tan chord theorem. Okay, right? So we've got the first angle that is equals to X. Now they needed 2. If we go to this circle, we know that AM is a radius and MD is a radius, and so it means that this and that, these 2 are equal. So AM will be equals to MD, which gives us an isosceles triangle. Now again, as I was saying, that your grade 8 geometry is also important. Now remember, with your isosceles triangles, we learned that the base angles are equal. So this will also be equals to X, all right? So D2 is also X, right? You can say base angles or isosceles triangle. AM, it's equals to MD. They both, it's a radius and a radius, which is equal. Okay, right? Now, we move on to the next question. Let's just put in what we have. This is X, and then this is also X. Prove that CM is a tangent at M to the circle passing through MED. Right? We need to find MED. So this is M. Where is E? Oh, okay. There's E, and then there's D. So in other words, we want to show that here we can actually draw a circle, right? Now, I have to prove that CM, this is CM, we need to show that CM is a tangent to this circle, all right? Now, drawing that, that circle, I can see that some of you are just looking at this and saying, okay, there's 90 degrees there, and you've got a diameter, then there's that angle, which is 90 degrees, exterior angle of a cyclic quad as equals to the opposite interior, okay? But now we can also look at it this way, that we need to show that this angle there This is angle between the tangent and the chord. So this will be our chord, should be equals to that angle. All right? Now, please be with me and shout if there's something you don't understand. All right? So now I need to work out this angle here, M1. But I can find M2, all right? M2 in the triangle, okay, you've got triangle A, M, D. There's a 90 degrees here, that's 90, plus that small angle, okay? So I can work out in that triangle, so I can have 90 degrees plus the unknown, which is your M2, okay? Let's just write M2. M2 plus X, okay, equals to 180 degrees, okay? So therefore, M2 is 90 degrees minus 2X. Okay, so we've worked out this, right? That is 90 degrees minus 2X. Now, that angle, because now these are angles on a straight line, all right? So it will be 90 plus 90 minus 2X plus the unknown, so we get 2X there, okay? So now, we need to work out this angle now, here, right? So we have, now remember, MD is a radius. EDC is a tangent. So in other words, we have a 90 degrees there, all right? So there is 90 degrees. There is also here, this is your 90 degrees minus 2X, right? So now if you take that 90 degrees minus 2X plus the 90 plus this angle equals to 180 degrees, so that's some angles of a triangle, then we get 2X here, right? So that will be 2X equals to that outside angle. So you can conclude now by saying, therefore, CM is a tangent to the segment M passing through M, E, and D, because you've got an exterior angle of a cyclic quad equals to the interior opposite angle of a cyclic quad. Now, some of you have looked at it as there's a 90 here, and there's also a 90 there, subtended by the same, subtended by the diameter, which is good, or exterior angle of a cyclic quad equals to the opposite interior angle. Okay, right? Now, we need to prove that FMBD is a cyclic quad. Okay, let's just get what we have here. There's X, okay? There's also X, proven above. And this was your 2X. And previously we had 90 degrees minus 2X. Okay? So now, what we need to work out is that FMBD is a cyclic quad. Now, we need to find F. There is F here. Okay, FMBD. Right? So, in other words, can we draw a circle around there? All right? Now, let's see. We've got this radius, okay, which is perpendicular to the tangent. So we know that this is 90 degrees, okay? And this here is 90 degrees minus 2X plus 2X. Is that right? If we add these two, you've got 90 degrees minus, that's, okay. All right, guys. So the easier way is to look at it as this is your 90 degrees. And if you add the two, you get another 90, which is 180. And you've got AMB as your your diameter, which subtends that angle, which is 90 degrees. And then you conclude by saying MFDB is a cyclic quad. And why is this a cyclic quad? Okay, because the opposite angles of a cyclic quad add up to 180 degrees. Because if you say M plus D, okay, this gives us 180 degrees. you've got a 90 degrees from the given information. Let's just look quickly here. You've got a 90 here. This is 90 degrees, okay? And this is AMB, which subtends this angle here, which is 90 degrees. So the opposite angles of a cyclic quad are supplementary. So that's the reason, okay? Right. Now, guys, we continue. Now, we need to prove that DC squared is equal to 5BC squared. Okay, guys, they've given us, we need to show that when we're working with this, at the end of the day, we get DC squared being equals to 5BC squared. Now, we need to find that DC, and we need to find the BC, okay? So now, you've got BC there, right? There is BC, and then we have DC, okay? But now there is an information here. There is MB as twice BC. So now if you look at this triangle, all right, we know that MD is a radius, and it's perpendicular to the tangent. So here we have a 90 degrees, all right? Now, what we can say here, we can use Pythagoras theorem here, and we know that MD squared plus DC squared equals to MC squared. Now, guys, at the end of the day, we want to make DC the subject of the formula, okay? So now, but I don't want MD in my equation, and I don't want MC in my equation. But there's something that I know, that MB is twice BC. So where I see MB, I can sub in to BC, all right? And at the moment, I don't have, but MB, it's equals to MD, right? I hope you all can see that from the center, okay, I'm drawing a line to the circumference. From the center, I'm doing a line to the circumference. So those two, there's a radius there, and there's also a radius MD, okay? So MD is the same as MB. So I can sub in straight away. This is MB squared plus the DC squared equals to, now, guys, MC, there is MC, okay? Now, to get MC, you need MB plus BC. So what we can say here is MC will be your MB plus BC. MB plus BC, but that is squared. Now, let's look at my final result. I need the DC and the BC, okay? Now, let's just look quickly. I've got the BC, I've got DC. Now, this I don't want, but it is given there that MB is 2BC. So I see MB, I can sub in with the 2BC. So this is 2BC, but that is all squared, plus DC squared equals to 2BC plus BC all squared, okay? Now, 2BC, but all squared, this gives us 4BC squared plus the DC squared equals to, now we have a 2BC plus BC, that's 3BC squared, which gives us 4BC squared plus DC squared equals to, now the 3BC, by the 3BC, you get a 9BC squared, okay? So therefore, I will make DC squared the subject, so DC squared will be 9BC squared minus 4BC squared, which therefore gives us DC squared, it's equals to 5BC squared. And I've just shown all the steps, okay? And that was we were asked to do prove that DC squared equals to 5BC squared. Worked it out with those triangles, and at the end of the day, you get your DC squared equals to 5BC squared. I hope you all following. Okay. Right. Now, let's see if we've got another question on this part. Now, we have to prove that triangle DBC is similar to triangle DFM. Now, we have to indicate these two triangles. It's DBC, okay? So there is DBC, okay? And then DFM. So there is DFM. Right? So this is what we are required to prove. Required to prove that triangle DBC is similar to triangle DFM. If we can get at least two angles that are similar in two triangles, then we can conclude that those two triangles are similar. Okay? Right. So now what we have. Okay, before I move on, Quinn, are they still following?
We have a quick question from Umihlali, and he asks, how do we prove a quad is a parallelogram? But I think that is
we'll
a
just
joke.
get, yeah,
Yes.
we'll get that one a bit
Alright.
later. Okay, right. Now, guys, what we did earlier on, we said this angle is equal to that, and this was also the same as that. Okay? Now, in triangle DBC, right? DBC, so this D, so D4 in DBC, D will be equals to your D on the other side, okay? Now, this is a triangle, F, let's just complete this triangle, FDM. Sorry, let's just get this out of the way. We're dealing with triangle DBC, so you've got D, and then you can put a B here, and then a C. Now on that other one, you've got F, M. Okay. Now we need to find another angle, okay, that is the same. Okay. So you've got the 90 degrees minus 2x. We worked this one out earlier on, okay, and what else? We have this one is 2x, right? From previous questions. Let's remind me. And this one was 90, okay? So that, if this is 90, that is 2x. This will be your 90 degrees minus 2x, okay? Right, so you've got 90 degrees minus 2x here, and then a 90 degrees minus 2x as M2, okay? So on the DBC, we have C, okay? We've got C equals to, C will be equals to your M, okay? So your M, so this, completing this one, so it's BCD equals to FMD, right? And then the first one, it was, okay, this one was proven above, okay? And then, as well as that one, we worked it out. So now we can conclude by saying, okay, the other angle will be equal to that other one, okay? So therefore, you must just follow, you've got your DCB will be similar to triangle DMF, angle, 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 right? So these two triangles are similar. The last one, the last angles will be the same, right? And we conclude that this is angle, angle, angle. Okay, I think we can just go for a break and we continue these questions.
All right, just before we go for the ad break, I'd just like to say, keep it up, mindsetters. I can see that you guys are helping each other out on the challenge question. And even Lebogang Maboka went as far as posting a picture of the worked out solution to the challenge question. So that is really, really good. I like that you guys are keeping the community going and you're helping each other out. But with that said, let's just take a quick ad break and we'll see you when we come back. Welcome back, Mindsetters. You are still with us for the grade 11 mathematics show with myself, Queen and Sihle. And a quick shout out to Unobala High School, grade 11, pre-matric. This is coming from Njabulo Brian. So shout out to Unobala.
Right, Nobalo, skip on. No holds. All right, guys, we continue with grade 11 Euclidean geometry. I know there's matrics that are watching as well, and they're also waiting for their show. But then grade 11, you can still move on to the grade 12 one. It's the same thing. We're doing Euclidean geometry today. All right, so for both grades. Now, the last question, we need to find the value of dm divided by fm. Now, where are we going to get that dm and the fm? It's from that proof of, we did similar triangles there. So we've got triangle DBC similar to triangle DFM, okay? Right, so the DM, now, this is what you do. Okay, we've got DM, right? So there's DM, okay? Divided by, so this is DM divided by DC, okay, no, sorry. So we've got DM and FM, okay? Over FM will be equals to, now we said DC, so that will be DC. Now we're moving the way we were moving on this other triangle. Okay, and then FM, this is BC. Okay, divide by BC. Okay, now we need to find the value of that. But earlier on in the question, a previous question, they asked us to prove that DC squared is 5BC. Okay, DC. We know that DC squared is 5BC squared. Now we need to look at the relationship between the two. So this and that, right? So I can make DC the numerator here and then BC the denominator. So let's work it out quickly. So if I divide by BC squared, so I've got DC squared divided by BC squared will be equals to 5, okay? Because I'm dividing on both sides by BC squared, right? So now I want to make DC divided by BC the subject, so I'm going to square root on both sides, so it will be plus or minus square root of 5, but the distance cannot be negative, so therefore DC divided by BC will be equals to the square root of 5. So DM divided by FM, it's equals to the square root of 5. All right. Now, guys, we move on. We've got the next question, question 3. Right. All right, and the figure FE is a tangent. Someone was talking about tangents just now, one of you learners, to the circle with center O, all right? So there's center O there. D and F are joined such that EG is equals to GF, all right? So EG equals to GF. If E3, if this is X, if E3 is X, name with reasons 2 other angles equals to X, right? From that statement, okay, we're given that GE, it's equals to, right, GE equals to GF, okay? And then this is an isosceles triangle, so it means that this will also be X, all right, the base angles equal. So the first angle that equals to X is F, right? So we say, okay, E3, it's equals to F, right? Both equals to X, and, sorry, the reason is, okay, isosceles triangle, or base angles equal, right? Now, they were looking for 2 angles, right? So the first one is that, and we are told that FE is a tangent. Okay, so we've got FE is a tangent, and there's a, just use, this is a chord, this is a tangent, angle between the chord and the tangent, this will be equals to that angle there. So this will also be X. So therefore D1 D1, it's equals to your E3 equals to X, and then that is your turn chord theorem. Okay, right, so you've got those two angles that are equals to X, right? Now let's just write them down. This is X, and then that is also X, and then we found that this is also X. Now, prove that DE it's equals to EF. Now we need to find where DE is and your EF, okay? There is DE, there is EF. Now, we need to tell that EF is equals to DE, right? Now, which will make that an isosceles triangle, right? But we already proved that D1 is equals to F, so therefore, this will be equals to that. Now, the fact that D1 is equals to F, okay, both equals to X, therefore, okay, that is proven above, therefore DE will be equals to EF, right? Base angles are equal, okay? Right, so you've done that 2 marks there, all right? Now, express in terms of X. Bar. Express who in terms of F? Okay, there's something missing here. We'll come back to this one. Okay, right? We need to express something in terms of X, right? We need to find there's something that's missing there. All right, so we're just moving straight to question 4. Okay? Now, with your question 4, in the given figure, AOB is the diameter of a semicircle, all right? So AOB is a diameter, so there's a radius OB and there's a radius OA, okay? And also radius there and then a radius there, okay? Now, prove that MB bisects NBO, right? So this is X, okay? Now, guys, watch. In order for us to show that MB, there is MB here. We need to show that MB bisects NBO. If this is going to bisect that, we need to show that this must be X. And then we conclude by saying that MB bisects NBO, right? Now, let us start. We know that MO, it's equals to MB, OB is the radius and that one also. So now, angle M, it's equals to angle B, both equals to X, and then isosceles triangle MOB, okay? So we've got X there, all right? And then another thing, guys, that we are told is that MO is parallel to NB, right? MO is parallel to NB, right? If this is parallel, then this angle and that angle should be the same. If those two, NB and MO, are parallel, then your angle M will be equals to B. So M will be equals to B, okay? Right, now that other one was MB. Oh, let's just specify here. The first one we said M is equals to B, and that B is in this triangle, OBM, okay? Now, the M again it's equals to that angle in this other triangle NBM. So this will be NBM, both equals to x. So now this, the reason it's alternate angles, right? And the reason is your NB is parallel to MO, okay? Now, we then conclude, therefore, MB bisects NBO, right? Because your what you call your B, let's just call this B1 and then that B2, okay? At your B1, it's equals to your B2, okay? Right. Now, question B, express MKN in terms of x, right? MKN. Okay. Now, where is this angle? MKN. All right. Now, guys, we have to be extra careful here. All right. You've got x here. All right. And what else do we know? We know that your ON, it's equals to your OB, right? I hope we're all following. Because I'm from the center to the circumference, so this is a radius. From the center to the circumference, this is also a radius. So if this is equals to that, then it makes the whole angle, this angle, will be the same as that angle, okay? So this one is x and x, okay? So it's x plus x, so that gives us 2x, all right? But we want this guy here, all right? Now, the KNB, so the KNB is a triangle, and we've got an angle outside the triangle, and that angle is K. So we need to express that K in terms of x, right? Now, what do we know from grade 8 is that the exterior angle of a triangle equals to the sum of the two opposite interior angles, right? So we would say MKN, it's equals to, now let's just check, we've got that x and the 2x. It's equals to x plus 2x, and this gives us 3x. So MKN, it's equals to 3x. All right? Now, next question. If it is now further given that x is 30, right, let's bring back what we have. This is x, okay? This is 2x, and that is your 3x. If it's given that x is 30, you need to find the sizes of angles of triangle MKN, right? So this is the triangle now. Is it MKN? Sorry. Okay. Is stake here. So there's a triangle MKB. You need to find the exact angles for MKB. All right? So now we've got K is 3x, right? And then B is x, all right? And N is 2x, right? But now we are told that x is 30, so this is 3 by 30. We get 90 degrees there for K. And then x is 30, and 2 by 30 is 60. So the angles of NBK, it's 60, 30, and 90. Now, the last question on this one is, hence explain why MOBN is a rhombus, right? Why is MNBO, it's a rhombus? And if you look at this, one of the properties of a rhombus is that their diagonals bisect each other at right angles. Okay, so now we got this one as 90, right? Your K is 90. So in other words, this one will also be 90. Angles on a straight line, this will be 90. That will be 90. So you can conclude by saying, therefore, MNBO is a rhombus. The diagonals bisect each other at right angles. Okay, right. Guys, I think for now, we can just quickly look at your challenge question. How's Queen?
Yes.
Right,
There's just a whole lot of answers coming in, different answers coming in.
Right, and-
Even I'm confused now, like which one
all
could
right.
be the right one.
Any options? The most frequent.
18 units. PA is equals to 18 units.
Yeah.
And we also have another one, Unkarabile. Well, she also says PA is equals to 18 units. Yeah.
Okay, so it means it was not challenging for them. Well done, grade 11s. Let's see if you all correct. In the diagram, O is the center of a circle, NAM, NAM, and OPA is perpendicular to MPN. 48 units equals to MN, all right? So there is MN, right? And now remember, this is your radius, right? If the whole distance is 48, then this will be your 24, okay? And then what else are we given? OP is 7. Okay, yeah, this was actually straightforward for them. Okay, right now let's work it out quickly. We want this PA, right? So we need to work out what PA is. But we have this triangle with 24, 7, and ON, okay? ON, we don't know what ON is. So ON, okay, squared will be 7 squared plus 24 squared. Let's just quickly work out that, right? 24, cool. Right, can you just calculate for me? 24 squared. This thing is giving me matata. Okay. All right, guys, there's some technical errors here. So 24 squared plus 7 squared, please work it out for me.
I don't have a calculator with me right now, but mindset is because of time, we will be posting the solution for you guys, so don't worry about that. And quickly before we leave you guys, can I just give a big ups and a congratulations to Umihlali Matlengana for winning himself this awesome Casio calculator. Well done, Mihlali, and congratulations. Mindsetters, grade 11s, if you guys don't have anything to do for the next upcoming hour, you can join us again for the grade 12 show, because we'll be doing a bit of revision which could be relevant to you and helpful. We will see you in the next show. Goodbye from me and Sihle. It's all.
Thank you. Cheers, guys.